Back in section 4.3, we talked about the idea of the Poisson distribution. And you might remember that that helped us to measure the likelihood of a certain number of occurrences that would happen in a given amount of time or space. So, like for example, consider this question here that I have below. Suppose that maybe arrivals at a bank, people that walk into the bank, follow a Poisson distribution, and there's an average of about 1.2 customers every minute that walk through the door. We could ask the question, what is the probability of having at least 4 customers arrive at the bank within the next minute? So again, you can kind of see here that we're asking a question similar to what this Poisson distribution can help us address. We're looking for a number of things that is going to happen, a number of customers that will arrive within a given amount of time or space. So if I was working a question like this, I would start by just identifying my random variable. I'd say something like, how about let's let x represent the number of customers that arrive at the bank. So that arrive at the bank within the next minute. Okay, well, I can see here then that x has a Poisson distribution, and I know that the value of lambda is, again, the average number of customers that show up every minute, and that was told to me to be 1.2 customers per minute. So again, all I'm really doing here is I'm following exactly what our formula sheet had always instructed us to do. Define a variable, state the distribution. The problem already told me that it was a Poisson distribution, so there was no reason to go through the checks, and identify lambda. And now I can run my actual calculator commands to compute this probability. So in this case, since I want the probability of having at least 4, that would be x is greater than or equal to 4, you might recall that I can tackle that almost with a CDF. I just have to go ahead and think about all the stuff that I don't want, which would be all the numbers of customers 3 and below, and I can compute this by doing 1 minus a Poisson CDF with my value of lambda at 1.2 and 3 for the value of x. So I can go ahead and crunch this out, and if I went to a calculator and crunched this, you could probably confirm that I get 0.0338. So it's not super strange to see how I might be able to visualize this problem as a Poisson distribution and to work through it. But what is kind of interesting here is what would happen if I was to change this question? What if I changed it and reworded it in the following way? What if I asked, what's the probability of having to wait over 1 minute for the next customer to arrive? Well, I might be able to see here right off the bat that a couple things have changed. A couple things have now been totally transformed by asking this new question. Notice now, am I interested in counting up a number of customers? Is that really the goal anymore when I ask, what is the probability of having to wait over a minute? Well, I'm not really interested in counting up customers. I can maybe say this. I could say here that the random variable has changed from counting customers to measuring time. I'm kind of interested in how long am I going to have to wait for this next customer to show up. You could almost imagine like you're in the bank staring at your watch constantly or something, right? Being like, gosh, when is this person going to actually walk through the door? So we've totally changed this. We could almost imagine creating an entirely new variable. Like let's say y is my new variable, and y is going to represent the amount of time we have to wait for the next customer to arrive. So this is, again, a very big switch here. But now the other thing that starts to seem like an apparent switch is that if I've changed from counting customers, and again, when I think about things that I would be counting, this is definitely the idea of something being discrete. It's something I could count with my fingers. But now I'm changing to measuring time, which is going to be continuous. So what I can see is that by changing this question in the way that we've done here, we can also see that the random variable is now continuous. But if my random variable is continuous, then I should note that we cannot use a Poisson distribution anymore. Because again, if I go and I look at my formula sheet, a Poisson distribution was, well, it was a discrete distribution. We've now migrated from a question that was at first glance a Poisson question, and with a little bit of reworking, we have changed to this backside of the formula sheet again. And actually what we've moved is to this second column. This is where 5.3, our current section, actually resides, in what we call an exponential distribution. In the next video, we'll talk about a little bit of what this exponential distribution is and how we use it, and how we can kind of see the similarities that it has to the Poisson distribution.